The core is stopping. The magnetic field collapse. They don't want you to see. The cockpit alarm chirped once, then twice, as the compass drifted 3 degrees east over Arctic haze. The captain glanced at inertial, then back at the needle. That can't be right. On the ground, a quiet NOTAM had already renamed the runway he was aiming for. Meanwhile, 500 kilometers up, a satellite over the South Atlantic clicked into safe mode. Again. Here's the part nobody wants to say out loud. The data hint the core's rhythm is wobbling, and your GPS, planes, and power grids ride on that beat. When that beat slips, your phone's maps jitter, your bank's timestamps wobble, your flights detour, and your lights ride closer to brownout on storm nights. Sensors keep catching hiccups. Official language stays careful. Tonight, we follow the receipts. You're going to see this play out the way operators and scientists lived it. First, as a nuisance, then as a pattern, then as a budget line. We start with navigation headaches, military and civil aviation logs where headings drifted just enough to force detours and runway renumberings. We'll pull on those threads into a lab world of iron, liquid metal flows, and seismic waves whispering that the inner core's rotation has slowed relative to the surface since around 2001. Slowed doesn't mean stopped, but it changes how the magnetic field breathes. We'll map the South Atlantic Anomaly, that soft spot over Brazil and the South Atlantic that satellites dread. Operators schedule safe modes crossing it. Some instruments lose data there. The European Space Agency's Swarm mission shows that patch expanded by an area nearly half the size of continental Europe from 2014 to 2025, with a faster weakening lobe southwest of Africa since 2020. Meanwhile, the magnetic North Pole sprinted at record speeds in the 2000s, then eased, still drifting toward Siberia. NOAA and the British Geological Survey pushed out the World Magnetic Model 2025 to keep phones, ships, and jets honest. We'll keep the stakes close to home. A weaker, wobblier field means more radiation jolts for satellites, timing errors for GPS, reroutes on polar flights, and extra heat in power grid transformers during storms. The myths? No, the field won't vanish overnight, and the core hasn't hit a hard stop. The reality is slower and messier and more dangerous to a civilization wired to precise timing. By the end, you'll know what's confirmed, what's likely, and what's hype, and exactly which systems bend first when the sky gets noisy. That's the promise. Let's start where the anomaly showed up first. The anomaly nobody could explain. The first clues didn't arrive as headlines. They arrived as paperwork. In a winter briefing, a flight operations manager slid a fresh chart across the table. The runway number at a northern base didn't match last year's. Earth's magnetic field had shifted just enough that the painted digits, the ones pilots line up with, were wrong. It's routine, sure, but the tempo was new. More runways were crossing the threshold faster. Someone joked the compass was getting moody. Nobody laughed. Meanwhile, dispatchers noticed peculiar drift reports on high-latitude routes. Compasses nudged east, then snapped back. Inertial navigation stayed steady. GPS still held, but the layer cake of trust was thinner. Military crews filed incident notes so dry you could light a match with them. Heading discrepancies of a few degrees, corrections applied, fuel impact noted. Then a cascade of quiet notices to air missions rolled out. Magnetic variation updates, minor resectoring of airspace. Nothing dramatic, just a drumbeat. Stakes creeping sideways like that. 3 degrees doesn't sound like a villain until you're landing in weather, or until extra track miles push reserve fuel math into the red. Polar flights are efficient until comms fade and the numbers don't agree. Add a solar storm day, and the margin shrinks again. Pilots learned to manage uncertainty, but uncertainty was getting bolder. While cockpits fought the needle, a different instrument underground started whispering. Geophysicists comparing earthquake doublets, quakes from the same patch, firing along nearly identical paths, saw travel time shifts through the inner core. It looked like the inner core's spin relative to the mantle had slowed since around 2001. Not a freeze, but a deceleration. Some datasets even hinted at slight backtracking relative to the surface. It's subtle, measured in tenths of a degree per year, but for the Geodynamo, subtle can be loud. In labs, liquid metal experiments and numerical models already showed that small changes in flow can alter the magnetic field's strength and geometry. The press took slowed and printed stopped. The scientists winced. They still do. But while the language got twisted, the sky put on its own demonstration. A few hundred kilometers up, the South Atlantic Anomaly grew teeth. Satellite operators had lived with it for years. A region where the protective magnetic field dips weak, letting radiation bite low Earth orbit hardware. You plan for safe mode passes. You harden your electronics. You accept lost data. But swarm's measurements showed the weak zone expanding since 2014, and a lobe southwest of Africa weakening even faster after 2020. On some orbits, instruments hiccup twice in one lap. Micro story. A satellite mission planner in Darmstadt watched the timeline turn patchwork. Good data here, blackout there. The client needed continuous coverage. The schedule couldn't deliver. A week later, a magnetometer test set confirmed what the sky had implied. The SAA wasn't just bigger, the gradients were sharper. Crosstalk between should be fine and definitely not fine got louder. Back on Earth, the magnetic North Pole continued its long walk out of Canada towards Siberia. In the 2000s, it sprinted near 55 kilometers per year, record pace, then eased to around 35 in recent years. Enough still to push the World Magnetic Model off schedule in 2019, then again with the 2025 release. The new model mattered to your phone, to ships at sea, to NATO's navigation suites, and to every airport planner deciding when to spend real paint and real money to change those runway numbers. Pilots didn't read swarm papers. They watched aurora forecasts. During active geomagnetic days, polar routes detoured south to keep communications and radiation doses reasonable. That cost fuel and time. Insurance actuaries noticed. They always do. What nobody could quite say in a single sentence was the thing holding all these threads together. The field was getting patchier. Not collapsing, but repatterning. Where it weakens, satellites suffer. Where declination shifts, charts and procedures chase the change. Where space weather hits during those windows, the compounding hurts. A second micro story. A maintenance chief at a high-latitude airport kept a sticky note under glass. Mag VAR today, check twice. It started as a joke. It didn't feel like a joke when 2 flights in 1 week called missed approaches in marginal conditions, both citing minor heading confusion layered on top of crosswinds and shifting minima. Nobody blamed the magnetics alone. In complex systems, causes arrive as teams. Meanwhile, the inner core result kept making the rounds. USC's team compared decades of seismic waveforms and found consistent evidence. The inner core's relative rotation had slowed after 201. Another group added a twist in early 2025, annual scale variability in both the rotation rate and the near-surface structure of the inner core. Shape and speed, both changing. Engineers heard variability, operators heard noise in the model, the internet heard stopping. Even careful headlines, slowed, backtracking, fed a mood that something fundamental was wobbling. Here's the urban legend temptation. Blame every glitch on the core. That's not how this works. But here's the sober through line. Navigation anomalies, satellite safe modes, rush magnetic model updates, and the growth of the South Atlantic Anomaly are not isolated stories. They're facets of a field that's dynamic on human timescales, more dynamic than our infrastructure budget assumed. Distrust started small. A pilot side-eyed a compass and favored inertial. A substation engineer scanned geomagnetically induced current alarms and bumped the night shift briefing higher on the list. A satellite operator added one more red block over the Atlantic. Multiply that across thousands of decisions, and you get a quiet cost nobody advertises. What nobody knew at the time was that the weak patch would keep spreading, and the poles would keep wandering. The models would keep up, mostly. The money would follow. And the human tolerance for invisible drift would get tested 1 degree at a time. While planes fought the needle, underground, a different instrument kept whispering. The whisper was about to sound like a drum. The core's subtle stutter. When the data blinked. To understand why cockpit needles started losing confidence, we need to go where the planet speaks in milliseconds. In seismology labs, researchers stack earthquake twins, same fault patch, near identical paths through Earth, until the noise cancels and only changes along the path remain. Those stacks are brutally honest. When waves that should match drift, something between the quake and the recorder moved or changed. Around 2010, that drift showed up in the PK-IKP phase, the wave that threads the inner core. Arrivals slid a hair later along certain paths. It was tiny, but consistent across decades of records. Soviet test waveforms archived since the 1970s, South Sandwich Islands repeaters from the 199s onward, and dense modern arrays. Pattern by pattern, the picture formed. The inner core's rotation relative to the mantle had slowed, easing from earlier super-rotation toward a near match, then slightly behind. Language matters here. Slowed isn't silence. The best estimates sit at tenths of a degree per year. Glacial to us, loud to the dynamo. Some analyses suggest slight backtracking relative to the surface after 2010. Others frame it as an oscillation, multidecadal breathing between faster and slower states. Then came a twist in early 2025, evidence for annual scale variability in the inner core's near-surface structure, right where freezing and melting feed the fluid outer core. Speed changed, texture changed. The gear didn't seize, it stuttered. Why should that move a needle in your pocket? Because the Geodynamo, our shield, runs on motion. Liquid iron convection, rotation, and the electrical currents they drive. Change the relative motion at the boundary, and you change shear, heat flux, and buoyancy where the loops get their fuel. This isn't an on-off switch, it's a throttle with feedback. Nudge it, and field geometry can reorganize. Strong lobes migrate, soft patches grow, poles wander. Action looked like spreadsheets and stubborn cross-checks. Teams compared travel time residuals with length-of-day wiggles. Millisecond changes as Earth trades angular momentum between core and shell. They lined up polar motion records, the Chandler wobble, the seasonal drift, against inner core inferences. No single dataset could carry the claim, but together they converged. Meanwhile, modelers ran numerical dynamos, nudging core, mantle boundary heat patterns by a few percent. Fields split, strengthened, weakened. Sometimes the dipole collapsed into a multipolar tangle before a new dipole emerged. Not predictions, possibilities mapping the terrain. What nobody knew then was timing. Would a slowdown at the center matter on human schedules? The press filled the gap with a word that sells: stopping. Scientists pushed back with careful sentences. Relative deceleration within expected variability. That lands like a shrug until you remember that GPS timing rides nanoseconds. Grids ride harmonics and aviation rides procedures, assuming the magnetic field won't outrun the charts. Variability isn't abstract when your systems are calibrated to yesterday. Meanwhile, parallel action, the sky confirmed the stakes. The South Atlantic Anomaly kept widening through the 2010s and 2020s, its West African lobe weakening faster after 2020. Satellite operators didn't cite intercore dynamics. They wrote new safe mode scripts and ate data gaps. The North Magnetic Pole sprint in the 2000s forced an emergency world magnetic model refresh in 2019. Then WMM 2025 arrived early to keep compasses and software honest. Caution in journals met urgency in operations. The gap bred suspicion. Impact came in rings. First, science. The slowdown sharpened debates. Are we watching a 60 to 70 year oscillation? Do annual scale structure changes at the inner core top imply faster coupling to the dynamo than we thought? A 2025 result said yes to the second, hinting growth, melting, and flow interact on year scales. Second, translation. Agencies updated FAQs, no overnight reversal. Yes, regional weakening can worsen satellite radiation exposure and navigation drift. Third, practice. Operators hardened thresholds. Insurers priced SAA transits more tightly, and navigation authorities tightened model cadences. Here's the complication. You can't wish away. Correlation isn't causation. Mantle convection and heterogeneous heat flux at the core mantle boundary mediate whatever the inner core does. Buffers filter and delay signals, but buffers don't erase them. They turn jolts into swells. The data blinking at depth didn't predict Tuesday's glitch. It reframed the baseline. The engine that powers our shield isn't a clock. It's a living machine with moods. A micro story from the lab. A grad student lined up 120-plus South Sandwich Island seismograms, old and new, and saw wiggles that matched not station changes but seasons. She tore the stack apart to kill instrument bias. The wiggles stayed. Their draft shifted from rotation change to rotation and near-surface structure variability. That nuance mattered downstream. If structure at the top of the inner core can change yearly, the outer core's flow can feel it faster, and the geomagnetic field can show it regionally within careers, not epochs. This was the moment the tone changed. Not doom. Discipline. The core hadn't stopped. It had blinked. Sensors caught it. Operators felt it as a tax on margin. More safe mode minutes, more chart updates, tighter timing budgets. And above, the weak patch that wouldn't sit still kept growing teeth. The South Atlantic Anomaly grows teeth. Operators had a nickname long before papers caught up: the bite. Cross the South Atlantic near local afternoon and you felt it. Bits flipped, detectors spiked, software dropped to safe mode and held its breath. That was the ritual. What changed was how often the ritual failed to keep pace. The weak patch has a proper name, the South Atlantic Anomaly, and it sits where the inner Van Allen belt sags closest to Earth, in that.
SAG, high-energy protons, dip low enough to sandblast electronics that anywhere else would be fine. For years, teams drew a box on a map, powered down touchy instruments, skimmed through, then brought everything back up and hoped the counters behaved. But in the mid-2010s, the edges started to creep. ESA's swarm satellites traced the field's intensity orbit after orbit, building a decade of receipts. By 2025, the weak region had expanded by an area nearly half the size of continental Europe compared to 2014. And, crucially, since 2020, a lobe southwest of Africa was weakening faster than the rest. A micro story. An imager over Brazil watched its schedule turn to Swiss cheese. The off window stretched, then split, as that African lobe deepened. 2 daily gaps became 3, sometimes 4, depending on orbital precession. A client asked why deliveries kept slipping. The ops lead tried to brief radiation like weather. The client heard delay. Hubble's cautious rules stayed cautious. Earth observers ran scripts. Cross the box, check particle counts, downshift if thresholds pop. CubeSats took the hit with thinner armor. Across fleets, single event upsets accumulated. Not catastrophic for any one bird, constant across the constellation. Hardened parts, ECC memory, watchdog timers, selective shielding, they all help. But every gram costs delta V. Every millimeter of aluminum steals power margin. You choreograph risk instead. Off here, on there, sprint when clear, sleep through the bite. Here's why growth matters beyond nuisance. If the weak zone broadens, more orbits intersect it, and for longer. Duty cycles shrink. That means lost images, deferred downlinks, and tighter onboard storage. As the minimum deepens, particle flux climbs. Even with care, the upset rate trends up. Lifetime shaved down not from a single storm, but from background abrasion. What nobody knew when Swarm first flagged the expansion was whether the split hinted by earlier NASA visuals would stick. Mid-2020's analyses said yes. The West African lobe slide quickened. The worst box moved. A rule written in 2018 was wrong in 2023, and wrong by more in 2025. Fixes weren't press releases. They were patches pushed to dozens of spacecraft, each with quirks baked at birth. Parallel action. Insurers watch claims evolve from isolated anomaly to recurring environment-driven upset. Premiums shifted. Reinsurers priced constellation exposure during solar maxima layered over SAA minutes. Procurement followed. Designers assumed more time per day inside higher flux, nudging choices toward rad-hard parts with longer lead times and budgets to match. A headache born in the core, mediated by physics, no clean room can control. Second micro story. A small-sat team launched on commercial-grade memory to hit a window. They modeled exposure with a 2016 map. 6 months later, logs showed triple the expected scrubs over Africa. They raised thresholds to limp along. Dynamic range suffered. Streaks crept into dawn scenes. The pictures told a story no memo could soften. It wasn't all weakening. Swarm saw strengthening over Siberia, even as a strong Canadian patch shrank. The field is patchwork, strong here, soft there. Satellites don't average a planet, they live their orbits. If your inclination spends more minutes over the South Atlantic, you inherit its temperament. On the ground, people didn't feel protons. Phones didn't crash because of the SAA. But the weather app might have missed a pass. A daily image skipped a rectangle over ocean. Quiet erosion, paid by engineers who set alarms for a box that won't stay still. This was the moment operators stopped calling the SAA an annoyance and started calling it a constraint. It's proof that regional weakening isn't academic. It's schedule, risk, and cost. One patch already messes with hardware.
If it spreads further, choreography tightens and margins thin. Meanwhile, a subtler cost rose: attention. Ops teams rewrote masks quarterly, then monthly. Students flying CubeSats learned hard lessons in real time. Vendors updated radiation curves mid-contract. Insurers adjusted deductibles after reading anomaly logs like tickers. All of it sits downstream of a shield that's breathing off rhythm. Here's the line that lands: the anomaly didn't punch a hole in the sky. It lowered the ceiling over a busy lane. Every pass under that ceiling is now a choice: collect less, risk more, or spend to survive. That choice repeats thousands of times a day, and the bill arrives quietly, in minutes you didn't plan to lose. The wandering poles, faster than we planned for. While satellites tiptoed through the bight, the compass rose itself kept sliding across the map. The North Magnetic Pole used to loiter around the Canadian Arctic. Then in the 200s, it bolted, accelerating to roughly 55 kilometers per year, arcing across the top of the world towards Siberia. Over the past few years, it eased to around 35 kilometers per year, still fast enough to outpace.
Paperwork and push procedures over thresholds that cost real money. Here's what that means when you hold a device. Your phone's heading isn't a simple magnet. It blends GPS timing, gyros, and a magnetic model, the world magnetic model, that turns true north and magnetic north into the same language. When the pole moves quickly, declination shifts faster than static charts can tolerate. That isn't a dramatic cockpit moment by itself. It's drift that turns into detours, recalibrations, and errors that accumulate on busy days when the sky is already noisy. Action looked bureaucratic, which is another way of saying expensive. In 2019, authorities pushed an out-of-cycle world magnetic model refresh because pole drift was pushing predictions out of spec. Then, in December 2024, NOAA and the British Geological Survey released WMM 2025, tightening the forecast and nudging millions of devices to update. Under the hood, it's spherical harmonics and data assimilation. On your screen, it's a patch. On the ramp, it's new paint. When magnetic headings cross a 10-degree boundary, runway designations change. 16 becomes 17, cascading into approach plates, FMS databases, signage, and training. Multiply that across airports, and the just paint joke dies fast. Meanwhile, Swarm kept showing the field's patchwork, strengthening over Siberia, while a strong Canadian patch shrank. The pole chases gradients like a marble rolling across a tilted table, leaving the Canadian lobes pull and drifting toward the Siberian one. Elegant in a model, messy in operations. The practical effect is a shifting reference that tests how quickly we can keep navigational truth synchronized across cockpits, bridges, and phones. Micro story. A harbor pilot off Greenland carried a dog-eared card with declination notes scribbled each spring. For years, the numbers ticked gently. Then they started leaping half a degree. He stopped trusting last year's card and checked the agency portal every week. One foggy morning, he caught a junior officer lining up an approach with an old chart. No lecture, just a steady hand on the wheel and a quiet reminder. The model is not a suggestion. Phones mask drift with software, but edge cases bleed through. Survey crews at high latitudes chasing baselines that won't sit still. Compasses behaving skittish when calibration lags. Military planners widening uncertainty bands near the pole. In aviation, runway renumberings have become a steady drumbeat. Training departments update memory items and sims to handle changes landing mid-cycle. Dispatchers fold WMM dates into the same calendars they use for IRAC cycles and nav database pushes. What nobody knew when the sprint started was how long the fast phase would last. The recent slowdown to about 35 kilometers per year isn't at all clear. It's a different slope. Even at that pace, forecasts degrade within a couple of years without fresh data. That's why WMM 2025 matters. It resets baselines, so compasses and guidance stay inside tight tolerances. For critical systems, acceptable error is a narrow door. Parallel action. Logistics teams learn the knock-ons. A runway number isn't just paint. It's thousands of references across JEP charts, NODAMs, databases, and training slides. Each change consumes attention, the scarcest safety resource we own. When the pole wanders faster, that tax arrives more often, and it lands during the same weeks hurricanes, blizzards, and space weather demand focus. And it's not just the north. The South Magnetic Pole meanders too, quieter in headlines because fewer people fly and sail near it, but still part of the same machine. The two-pole story reminds you that geometry shifts are global, even when impacts feel local. A ship in the Southern Ocean, a plane in Nunavut, a survey crew in Lapland, each experiences the same field as a different puzzle. Here's the line that ties it back to the bite. The flows that tug the pole are the flows that sculpt weak patches. If the pole's path forces model updates and runway paint, those same subsurface gears are also lowering the ceiling over the South Atlantic. Navigation must sprint to keep headings honest. Satellites must duck to keep sensors alive. It's one system seen from two altitudes. Another micro story. A regional airline safety chief built a tiny ritual into pre-flight. Verify the magnetic variation on the FMS against the fresh WMM value when operating above 60 degrees north. It added 20 seconds to a checklist. A month later, a crew caught a half-degree missync that would have grown into a bigger discrepancy on a day with crosswinds and low ceilings. No drama, just weight shaved off a stack of risks. So the wandering poles aren't trivia. They're the quiet metronome behind a lot of routine work. Keep models tight, paint when thresholds cross, brief the drift like weather, because the machine underneath, hot metal, rotation, and feedback, doesn't keep time for us. It keeps time for itself, and when it's rhythm. Shifts, we either move with it or let errors pile up until a storm day cashes them in. How the Geodynamo breathes and trips. To see the shield we live under, you have to look into a river you'll never see. 2,900 kilometers down, the outer core is a global ocean of molten iron alloys. It moves, not like boiling soup, more like a dense, disciplined storm. Jets, eddies, and slow spirals form where heat escapes unevenly through the core mantle boundary. Motion in a conductor makes electrical currents. Those currents make magnetic fields. Those fields push back on the flow that made them. That loop is the Geodynamo, and it doesn't tick like a clock, it breathes. The breath starts at the boundary. Rock above the core isn't uniform. Subducted slabs chill some regions, deep plumes warm others. Where heat leaves faster, convection strengthens. Where it leaves slower, flow slackens. Add Earth's rotation, and you get tall, column-like circulations, Taylor columns, aligned roughly with the axis. They bundle magnetic flux into lobes that drift, split, and rejoin. Strong lobes help lock in a tidy dipole. When the balance shifts, geometry changes. Poles wander, regional weak spots grow, and the neat dipole frays toward a messier multipolar pattern. We can't build an Earth, but we can cheat. In labs, researchers spin tanks of liquid sodium or gallium, seed tiny fields, and watch instabilities flicker. Columns split, jets precess, patches of field wander, weaken, then pulse back. In supercomputers, numerical dynamos push the physics deeper. Nudge the heat pattern at the top a few percent, and the model's field reorganizes. Flux lobes migrate, polar caps reshape, and in some runs, the dipole collapses before a new dipole emerges with opposite polarity. Those aren't prophecies, they're maps of what's possible when the engine's inputs change. Now connect that to the blink we heard from the inner core. It's solid, it grows by freezing at its top, and growth releases light elements into the liquid above, buoyancy fuel. If the inner core's rotation relative to the mantle slows, or even backtracks slightly, the shear at that boundary shifts. Freezing and melting zones adjust. A 2025 result added something bolder: annual scale variability in the inner core's near-surface structure. Speed changed, texture changed. That means the fuel lines feeding the outer core's flow can modulate faster than we assumed. Year to decade, not only century. Earth's rotation joins the dance. Tiny length of day wiggles, milliseconds, are fingerprints of angular momentum trading places between fluid core and solid shell. When those wiggles line up with seismology's story, modelers get braver about coupling. The system has gears. None of this draws a straight line from inner core stutter to your compass today, because the mantle's uneven heat flux filters and delays signals. But filters don't erase. They smooth jolts into swells that reach the surface as pole wander here and a soft patch there. Stakes land in the patchwork. The South Atlantic Anomaly looks like flux lobe rebalancing. Field lines bowing low enough to let trapped protons dip into satellite lanes. Over Siberia, strengthening suggests a counterweight. That chessboard is exactly what simulations predict when boundary heat shifts or coupling changes. Not weak everywhere, but strong and soft squares migrating across the board.
Action for people shows up as design choices. Operators don't manage a global average. They manage the square their orbit, runway, or pipeline lives on. If the dynamo breathes deeper, longer weak patches, faster drift. Satellite teams add error-correcting memory, latch-up protection, and selective shielding, then choreograph safe mode naps through hotter zones. Grid operators install magnetometers and GIC sensors at substations. Tie them to procedures with thresholds. Block automatic switching, hold voltage, bring extra spinning reserve online. Aviation tightens polar protocols. Pre-brief HF fade risk. Plan detours. Update models on schedule so headings don't surprise anyone on short final. History sets the tempo. Full reversals in rock take thousands of years. Excursions, the near flips, compress stress into centuries and sometimes sharper surges inside that. Neither is a Tuesday surprise, but both say the engine likes to reorganize when thresholds are crossed. And thresholds don't announce themselves with a headline. A few more watts per square meter of heat outflow here, a slight shear change there, and a tidy dipole sags into a patchwork that lets routine storms punch above their weight. Impact looks like quiet costs before big nights. More spares for big transformers that take months to build. More frequent world magnetic model updates and training that assumes headings won't sit still. Extra kilograms of shielding that steal propellant margin. On storm weeks, the bill comes due. GPS accuracy bands swell at bad hours. Satellite duty cycles shrink. Grid operators shed load to avoid cooking steel. Airlines detour. None of that requires a flip.
Wobble is enough. There's one problem planners hate. The line between breathing and tripping is blurry in real time. By the time you know a threshold got crossed, you're already writing the after-action report. That's why the right posture is weather style. Forecast, thresholds, drills, dashboards. Treat the field as living background, not wallpaper. Because the river under our feet doesn't care about our deadlines. It moves on its schedule. Our margin depends on noticing when its breath gets shallow and acting before the next storm asks if we did. Reversal versus excursion, timelines and myths. Rocks don't do height, they do memory. Basalt flows cool and lock in the field's direction like millions of tiny compasses. Seafloor spreads and writes a barcode of flips. Lake mud and ice layer up annual pages that catch the quick swerves. Stack those witnesses and you get two tempos, reversals and excursions. Reversals are the long game. In the paleomagnetic record, full flips unwind over thousands of years. The neat dipole weakens, directions wander, multiple poles can show up at once, and eventually, the polarity settles the other way. It's messy and slow on human terms. Your grandparents don't wake up to south where north was. Your great-great-grandchildren notice the outcome, not the turn. Excursions are the sharp detours. They're near flips that don't finish the job, centuries long, sometimes with decades where the field weakens fast and directions go weird, then snap back to the original polarity. The Laschamps excursion, about 41,000 years ago, is the cleanest example. Lava in France and New Zealand records wild bearings for a brief window. Ice cores show beryllium-tin spiking, a sign the shield strength fell to a small fraction of normal for a short time. Some reconstructions argue auroras marched toward lower latitudes. Ozone chemistry likely shifted. Climate nudged regionally. Humans were there, painting caves, wearing clothes, adapting. No mass die-off tied to magnetism, but the sky behaved differently, and that mattered. Stakes for us live in tempo. Civilization runs on decades. Airports, satellites, grids, finance. Those investments live 5 to 20 years at a time. A 1,000-year reversal does pressure. It doesn't slam. An excursion can line up with a lively solar cycle and turn the next 20 years into a stress test. You don't need a flip to feel it. A wobble on a weaker baseline means more satellite upsets, rougher GPS in a stirred ionosphere, more polar detours for radiation and comms, and higher geomagnetically induced currents heating transformers for the same solar punch. Now, the myths that keep messing up the brief. Myth 1, the field can vanish overnight. It can't. The Geodynamo doesn't have a known off switch. Even during reversals and excursions, a field persists, messier, multipolar, weaker in spots, stronger in others, but not zero. Myth 2, a flip equals instant apocalypse. The fossil record doesn't show extinctions lining up with reversals. Life rides them out. The modern risk isn't biology, it's technology. Myth 3, the core stopped. The best evidence says the inner core's rotation slowed relative to the mantle and may oscillate, with hints of slight backtracking and year-scale structure changes at its top. That's a variable gear, not a seized engine. Here's what the rocks tell us that should change behavior now. 1. Regional patchiness is normal during both reversals and excursions. That's the family tree the South Atlantic Anomaly belongs to. Weak here, strong there, shifting with the flows. 2. Direction can swing wildly in some places while barely budging in others. For navigation, that means treat the compass as context, not gospel, and keep the world magnetic model fresh, so software can reconcile magnetic and true. 3. The steepest parts of an excursion can bite within human plans. That's not a headline to panic over, it's a procurement note. Harden satellites for a rougher background, put GIC sensors on substations, build polar protocols that assume more frequent comm fades and radiation watches, teach the thresholds like weather. What nobody can give you, honestly, is a clock. Models can explore thresholds. Paleo records can show frequency bands. But no one can data reversals, start or call an excursion a decade out. The responsible stance is scenario planning. If the South Atlantic Anomaly keeps spreading and deepening on recent trend lines, and if pole drift keeps forcing out of cycle model updates, what changes in the next 5 to 10 years of your systems? If it relaxes, what does that save? Set ranges, tie actions to thresholds. One more truth from Stone and Ice. Volatility is normal over centuries. What's not normal is our dependence on nanosecond timing and electrons in long lines. That's why this matters, even if no flip shows up this century. A weaker patch plus a busy sun equals more weeks, where satellites sleep longer, grids run hotter, planes detour, and timing drifts unless redundancy holds. You don't need doom to justify a checklist. You need receipts. And the rocks, the satellites, and the poles just handed them over. The fragility map. Satellites, grids, and planes. Lay the systems out like a map. Above us, through us, around us, and you'll see the same invisible hand pressing on different nerves. Start in orbit. Satellites don't fail dramatically, they fray. In a weaker patch like the South Atlantic Anomaly, high-energy protons slip lower and smack electronics that anywhere else would shrug. One hit flips a bit in memory. A watchdog catches it and corrects. Another hit lands in a timing register. A wheel spins when it shouldn't. Software drops to safe mode and waits. None of this is rare anymore over the South Atlantic. The expansion since 2014 turned a tidy no-go box into a moving shoreline. Operators respond with choreography. Power down sensitive detectors inside fresh masks, raise particle thresholds, schedule naps through the bite, and sprint outside it. Error-correcting memory, latch-up protection, selective shielding, they all matter. But every gram of shield steals delta V. Every defensive routine steals minutes. Duty cycles shrink. Data gaps widen. During a lively solar cycle, drag joins in, the thermosphere puffs, low-orbit birds lose altitude faster, and propellant burns creep forward on calendars. Missions still work, margins thin. And GPS, the quiet glue, feels it indirectly when storms stir the ionosphere, bending signals and adding jitter that timing receivers have to ride out. Parallel action on the ground, long wires listen to the sky, geomagnetic storms drive electric fields across continents. High voltage lines and pipelines act like antennas, pulling quasi-DC currents into big transformers. Cores heat, steel saturates, protection relays, see ghosts, reactive power swings, voltage sags. Operators know the drill. Block automatic capacitor switching. Hold voltage set points tighter. Bring extra spinning reserve online. Postpone maintenance on stress corridors, and be ready to island if the oscillations won't sit down. The difference in a patchier field is simple and cruel. The same storm pushes higher geomagnetically induced currents in the same places. Quiet erosion shows up as accelerated aging of transformers that take months to build and move. Loud nights show up as controlled load shedding to save the big steel. Timing rides this backbone. Cell towers and trading floors discipline their clocks to GPS. When ionospheric scintillation makes GPS ugly, good holdover clocks keep time for hours. If you cheaped out, drift creeps in and cascades into drop calls, desync packets, and system alarms you can't clear with a pep talk. Now the planes, the part of this story humans feel in their bones, Polar routes shave time and fuel, but they perch where space weather hits. Communications and radiation hardest. On an active day, high-frequency radio fades, SATCOM drops packets, dosimeters tick faster, airlines carry playbooks, pre-brief space weather advisories, detour south when blackout risk rises, adjust altitudes, add fuel, and rotate crews. Those choices cost money and time, and they land on weeks when everything else is already wobbling. On routine days, magnetic drift is paperwork. Runway renumberings, fresh procedures, updated models loaded into FMS so heading references agree with the new paint. On noisy days, drift plus a storm means dispatchers rewriting tracks mid-shift, pilots juggling comm handoffs, and maintenance chiefs double-checking databases against WMM updates, because a half degree out of sync on a low ceiling day is the kind of nonsense that steals margins at the worst moment. Thread a micro story through all three. A storm window opens on a Thursday. In orbit, a weather bird spends extra minutes in the South Atlantic Bight because the weak lobe near Africa deepened again. Safe mode scripts fire early, late, twice. Flood maps arrive after the crest. On the ground, GIC sensors at a substation nudge past thresholds. The operator blocks auto-switching, calls for more reserve, and sheds industrial load for 2 hours to keep a known weak transformer from cooking. In the sky, 2 polar flights divert, burn extra fuel, and land late. Connections evaporate. Crew duty times get tight. No one headline, just friction. Data late, electrons hot, airplanes south, stacked into a day that didn't need help being hard. Insurers notice before the public does. Satellite policies carve out exposure over the South Atlantic more explicitly. Deductibles creep up unless you can show mitigation. Shielding grams, error correction rates, updated SAA masks. Reinsurers build geomagnetic variables into catastrophe models for utilities. Bond markets price grid hardening and spares differently for regions that light up magnetometers. Aviation underwriters nudge premiums when polar detours become routine. Money is a seismograph. It registers tremors in operational.
Logs long before press offices do. Here's the fragility map in one line. Anywhere codes ride on precision, and electrons ride in long lines. A wobblier shield turns routine storms into bigger chores. Satellites cope with armor and choreography, but their lifetimes and duty cycles tilt. Grids cope with sensors, procedures, and spares, but their weakest links warm faster under the same punch. Planes cope with playbooks, but costs and doses climb in bad weeks. Stack them, and you don't get cinematic collapse. You get cascading inconveniences that on the wrong Thursday turn into real outages. The fix isn't panic, it's rhythm. Dashboards, thresholds, drills, and paying the small costs now so the big ones don't all arrive on the same day. Rocks that remember, clues in stone and ice. If you want proof the field can swerve on human-relevant timescales, you hike where the planet kept its diary. Lava writes in iron. When a basalt flow cools, tiny magnetic grains align with the local field and lock that direction like a million frozen compasses. Geologists core those flows, carry them to labs, and spin them in magnetometers. One core is a whisper. A stack of cores across ages becomes a map of where north lived and how fast it moved, long before runways needed new paint. The oceans keep longer ledgers. As magma rises at mid-ocean ridges and spreads, it cools and records the field's polarity. Because the field has flipped many times, the seafloor holds symmetrical magnetic stripes on either side of the ridge, barcodes of past reversals. Those bands let us time flips across millions of years. The last full reversal, the Brunes, Matiyama, sits around 780,000 years ago. Its transitions smear across thousands of years, not days. That's the big tempo. Slow turn, eventual settle. But the quick moves, the ones that matter to budgets and careers, hide in finer layers. Some lakes lay down annual sediments like tree rings. Magnetic grains in those layers capture sharp directional swings year by year. In polar ice, the record isn't direction, it's fallout from space. When the magnetic shield weakens, more cosmic rays reach the atmosphere and forge extra beryllium-10 and carbon-14. Those isotopes spike in ice and tree rings when the sky lets more radiation through. Match those spikes with lava directions and lake ring wobbles, and you get timing, intensity, and pace. The cleanest detour in that record is the Laschamps Excursion, about 41,000 years ago. For a short window,
The shield sagged so hard the sky changed color at the equator. Auroras pushed far south. Cosmic rays flooded the upper air, and ozone chemistry shifted under the assault. Regional climate nudged. Night after night, the horizon glowed in places that never see it today. Humans were there to feel it. They sheltered in caves, painted by firelight, and waited out a sky that wouldn't behave. No extinction, no switch to zero. But for a human lifetime, the world above was louder and stranger than anything we know. And that was before GPS, power grids, or satellite timing had anything to lose. Zoom in on the lesson. 1. Volatility is part of the system's language. Regional patchiness, strong here, soft there, is normal during excursions and the ramps around reversals. That's the same family the South Atlantic Anomaly belongs to. 2. Direction can swing wildly in some places while barely budging in others. Navigation that treats magnetics as gospel will stumble. Navigation that treats magnetics as a model, updated on schedule and blended with GPS and inertial, will cope. 3. The steepest parts can bite within decades to centuries. That's not calendar doom, it's procurement math. A field micro-story from the rock side. A grad student in Iceland leans into the wind over a young basalt flow, drills a warm core and labels it with cold fingers. Months later, in a lab, the magnetometer trace wobbles, then settles 90 degrees off today's north. It feels wrong until the next core agrees, and the next. Her map fills with arrows that don't point where intuition says they should. That moment, when stone contradicts your gut, changes how you treat drift reports from planes and safe mode logs from satellites. The rocks are telling you. The field can move fast enough to matter to people. Meanwhile, in a cold room, a technician slices blue ice and counts beryllium-10 atoms. The curve rises where the shield sagged. When those peaks line up with weird lava directions, confidence jumps. When they don't, dates get rechecked until they do or the hypothesis dies. It's slow, fussy work. But it pins what models can only suggest. The engine reorganizes. Not weakly. Often enough that a modern grid planner and satellite designer should respect the tempo. Here's the bridge to now. No rock predicts a flip this century. But they constrain the edges. Full reversals are slow. Excursions compress stress. Patchiness is normal. If today's South Atlantic soft spot keeps growing and the pole keeps wandering faster than our grandparents saw, the paleo record says that's not a glitch. It's how the system talks. We don't answer with panic. We answer with habits. Keep field models tight, harden where the map is soft, treat the sky's mood like weather, and act before a storm asks if we did. The quiet fight, science versus messaging. While rocks, satellites, and runways kept handing out receipts, another story played out in edits and inboxes. Scientists hate overselling. Operators hate scaring customers. Agencies hate headlines that turn nuance into panic. Put those instincts in one room and you get careful sentences walking a tightrope over real stakes. Start with why the tone stays quiet. Panic has a price. Say magnetic field weakening without context, and you get bad travel takes, stock jitters, and angry calls from insurers. National security sits in the background too. Navigation and timing are strategic, so no one rushes to broadcast soft spots. Liability lurks. If a utility admits a transformer is vulnerable during a hot storm window amplified by regional weakening, a lawyer somewhere highlights the sentence. So the public line leans conservative. No imminent reversal, systems are robust, we have mitigation. Inside the rooms that matter, the dashboards say otherwise on bad weeks. More safe mode minutes, tighter timing margins, higher GIC thresholds. They know, they just package it. Meanwhile, researchers publish with surgical caution. A seismology team writes, inner core deceleration relative to mantle, possibly slight backtracking, consistent with multidecadal variability, plus annual scale changes near the top. Accurate, and for most readers, opaque. A geomagnetism brief says South Atlantic weakening since 2014. Strengthening over Siberia, uncertainty remains. Also accurate, and it lands flat when ops teams are rewriting safe mode masks because the weak lobe shifted 200 kilometers. Agencies try to translate. NOAA and BGS push WMM 2025 with clear guidance. Compasses drift, models updated, keep your software current. ESA showed swarms maps of the South Atlantic Anomaly's expansion and reminded everyone that life on the ground is fine while spacecraft take the hits. NASA's visuals captured the SAA split into lobes and mission procedures around it. The intended takeaway is simple: dynamic, not catastrophic. The unstated part: operators and insurers already price this in. Policies carve out SAA exposure, premiums hinge on shielding grams and ECC rates, and mission plans budget lost minutes under the bite. The circle knows. The press release trims the edges. Then the internet kicks the door. Creators, some careful, some not, collapse inner core relative slowdown within expected variability into thumbnails that say, "Core is stopping." Scientists sigh. The algorithm shrugs. In that noise, the middle message gets drowned. A pilot hears a terse notum, a viral video, and a measured FAQ. Guess which one sticks in a tired brain at 4 a.m. before pushback? A micro story from the messaging trench. A comms officer drafts a blog about the SAA's growth. The scientist adds uncertainty, bans, and caveats. Legal strips verbs that sound causal. The final line reads, "Operators have procedures." True and useless to a student team asking if their CubeSat's memory will survive over the Africa lobe. 2 weeks later, a magazine runs, "Giant hole in Earth's shield." Also wrong. The operator's reality sits between. How big, how fast, what thresholds, what to change. Motivations matter. Space agencies want launches to happen, and missions to return data. Highlight risk without tools and budgets get cut. Utilities want regulators to fund resilience. Scare ratepayers without a playbook and you get backlash. Airlines want predictability. Broadcast polar route risk without alternatives and you spook passengers. The right tone is sober urgency with numbers, thresholds, probabilities, timeframes, mitigations tied to dials people can see. Here's the part people feel but rarely hear. Agencies, operators, and insurers already act like the risk is real. They just talk like it's remote. Ops teams push patches, widen SAA masks, and reroute flights. Underwriters raise deductibles unless you prove mitigation. Utilities train night crews to block switching when magnetometers twitch. The silence isn't ignorance, it's strategy. Trust is what cracks when tone misses. A runway number changes, a satellite misses a pass, and the explanation feels sanded down. Conspiracies fill the silence. Then, on the day agencies actually need attention. Storm window tomorrow. Expect GPS accuracy bands to widen. Here's what to do. The audience splits between cynics and doomers. That's the cost of years of overcautious comms and engagement-chasing thumbnails. So what does better look like? First, shared dashboards. Put real-time magnetometer traces, GIC at substations, ionospheric scintillation, and satellite anomaly rates in one public window with plain thresholds. Green, yellow, red, and actions. Green means normal ops. Yellow means prep. Postpone non-urgent maintenance. Load updated SAA masks. Pre-brief HF fade. Red means execute. Shed discretionary load, detour polar tracks, tighten timing holdover. Second, pre-bunking. Before Solar Max, agencies and operators co-author what to expect when the sky is noisy, with examples. How much GPS accuracy degrades, how often polar detours happen, what grid procedures trigger at which field strengths. Third, timelines as ranges, not predictions. If the SAA continues at recent rates, here's the 5-year exposure map. If it slows, here's the other envelope. Tie procurement to both. Fourth, admit uncertainty without hiding impact. We can't forecast reversals. We can forecast tomorrow's storm. We can show how a weaker patch raises upset rates or G for the same solar punch. Fifth, incentives. Reward teams for publishing operational lessons learned. Anomaly rates versus SAA minutes. Grid responses versus local magnetometer thresholds without punishing them for transparency. Insurers already read these logs. Let the public read a digest that teaches. One more micro story. An airline safety chief and a utility ops lead sit in the same room for once. They watch the same magnetometer spike and agree on a color. The airline shifts 2 polar tracks. The utility blocks auto switching and brings reserve online. The city's emergency office posts a simple banner. Yellow today. Expect GPS hiccups and HF weirdness. No action needed for the public. That's the tone. Adults talking to adults, receipts on the table. No drama where none is needed. Most days will be fine. Habits form on those days. Treat magnetism like weather. Check the dashboard, brief the thresholds, act, move on. When the sky gets loud, the conversation's already started, and nobody needs a thumbnail to find the truth.
What's confirmed, what's likely, what's hype. Let's pin down what we know, what the odds favor, and what to throw out. Clean, specific, and tied to the receipts you've seen. Confirmed first. The North Magnetic Pole sprinted across the Arctic in the 2000s at roughly 55 kilometers per year, then eased in recent years to around 35 kilometers per year, still fast enough to force navigation updates. That's why 2019 saw an out-of-cycle World Magnetic Model refresh, and why WMM 2025 landed in December 2024, so devices, charts, and flight decks wouldn't drift out of spec. Those updates weren't theory, they were maintenance on the reference frame your bearings depend on. Also confirmed, the South Atlantic Anomaly expanded measurably between 2014 and 2025 by an area almost half the size of continental Europe, while a lobe southwest of Africa weakened faster since 202. Operators responded in the only way that works: more safe mode minutes, adjusted thresholds, revised radiation masks, and in some cases, reduced duty cycles. Logs from fleets, legacy birds to CubeSats show higher rates of single event upsets over that region. Not catastrophic per craft, constant across the constellation, confirmed in the physics. Satellites and polar aviation feel space weather. On active days, low-orbit satellites face more drag, more memory scrubs, and more time in safe mode over the SAA. HF comms fade on polar routes. SATCOM gets noisy. Airlines detour to manage radiation and communications. Grids see geomagnetically induced currents that heat transformers and trip procedures. Block auto switching, hold voltage set points, bring reserve online, postpone maintenance. None of this requires a reversal. It's how a dynamic field plus a lively sun behaves. Now, it's likely. The inner core's rotation relative to the mantle slowed around 201 after an era of superrotation. Multiple datasets point to an oscillatory pattern on multidecadal scales, and 2025 work adds annual scale variability in near-surface inner core structure. That mix likely modulates outer core flow, the Geodynamo's fuel lines, on decade to century horizons. Not a switch, a throttle. Expect continued regional reconfiguration, strengthening over Siberia while the South Atlantic stays softer, with pole drift that occasionally outruns 5-year model cadences and forces early corrections, just like 2019. It's also likely we'll see more SAA-driven operational constraints for small sats that fly commercial memory and tight power margins. Constellations with redundancy can lose minutes and hide the gaps. Singletons pay in data and lifetime. During solar maximum windows, layering ionospheric scintillation on a patchier baseline will degrade GPS accuracy more often and for longer, forcing receivers to lean harder on good holdover clocks and multi-frequency mitigation. Insurance pricing and procurement already reflect this. Premiums inch up unless you can show shielding grams, ECC rates, and fresh SAA masks in code. Likely on the ground. Grids that add GIC sensors and tie them to thresholds will ride storms better than those that wait. The same storm will push higher GIC in the same soft regions as the baseline drifts, so procedures and spares make the difference between a long night and a long outage. Aviation will keep polar protocols tight. Pre-brief, HF fade, dose watches, predefined detours, because the cost of a wrong bet is bigger when the ceiling lowers over the South Atlantic and the pole won't sit still. Now the hype to drop. The core has stopped. No, the best evidence shows slowdown and slight backtracking relative to the mantle within a longer oscillation, plus year-scale structure changes at the inner core's top. That's a variable gear, not a seized engine. The magnetic field will vanish overnight. No, even during reversals and excursions, a field persists, messier, multipolar, weaker in places, but not zero. A pole flip equals instant apocalypse. No, full reversals take thousands of years. Excursions compress stress into decades, but neither has a track record of killing ecosystems. The modern risk is technological: timing, comms, power, and the cost of keeping them steady. Also hype. Runway renumberings prove collapse. They prove drift and diligence. Airports change paint when headings cross thresholds, so cruise eyes and databases agree. A giant hole over Brazil. The SAA is a weak patch over the South Atlantic that bites spacecraft. Daily life on land continues. Days with no compass. Local declination can swing, but models plus GPS and inertial keep navigation tight when software is current and procedures are clean.
One last seductive myth. We can predict the flip. We can't. Models map thresholds and probabilities. Paleo records give frequencies. No clock exists. The useful posture is scenario planning. If the SAA keeps spreading on recent trend lines, what grams, watts, and minutes change in your design? If pole drift outruns model cadence again, what workflows update?
Faster? Why the precision matters is simple. Bad framing burns trust and budgets. Say stopping, and you get panic and backlash. Say nothing burger, and the ops teams living the minutes stop listening. The sentence that moves procurement is the middle one. The field is dynamic on human timescales. Some regions are weakening, while others strengthen. Operational impacts already exist. Modest resilience buys down outsized risk. So write the board notes in plain language. Keep WMM-IGRF integrations automated. Treat SAA evolution as a design input. Expand magnetometers, ionospheric sensors, and public dashboards. Drill thresholds across sectors. Price risk where it lives. And remember the psychology curve. Slow change normalizes until one storm caches every deferred decision on the same week. The goal isn't drama. It's fewer surprises when the river under our feet takes a deeper breath. Act Alum, the Preparedness Playbook we aren't using. Preparedness isn't a bunker, it's a checklist. And right now, too many boxes are blank. The field is breathing off rhythm while the sun gets louder. That's not an omen, it's a workload. Treat it like weather. Forecasts, thresholds, playbooks, drills. Start where the minutes are already leaking. Space, grids, aviation, and then land it at your desk and your door. Space first. You don't need battleship shielding. You need armor where bits flip. Harden the memory that holds state, the power rails that latch up, the timing that keeps the attitude loop honest. Error-correcting codes, watchdog timers, current limiters, and selective shielding around the most sensitive chips. Those pay back. Then choreograph smarter. Push dynamic SAA maps and particle counts to spacecraft so thresholds adjust in real time, not from a map printed 2 years ago. Let instruments nap through the bite and sprint as soon as flux drops. Bake in on-orbit reprogrammability, so protection logic evolves as the weak lobe shifts, and stop flying half-blind. Expand low Earth orbit magnetometers and particle monitors. Stream their feeds where operators, students, and insurers can see them. If everyone shares the same radiation weather, planning gets cleaner and arguments get shorter. Grids next. Steel survives with awareness and habits. Install GIC sensors at substations and tie them to simple triggers. When currents exceed a line, block automatic capacitor switching. Hold voltage set points tighter. Bring spinning reserve online, postpone maintenance. Train crews with live magnetometer data, not tabletop hypotheticals. Run drills where you island, reconfigure, and ride a storm without touching reliability margins. Build transformer spares programs with the logistics solved on paper before a bad week. Who gets what, from where, how fast. Wire utilities into space weather alerts with color codes people can act on. Green, yellow, red with actions attached. Green, normal ops. Yellow, prep, delay non-essential work. Watch JIC and voltage swings. Call in extra eyes. Red, execute, shedding discretionary load, redispatching, holding until the sky calms. The data exists. The loop from dashboard to switch is the gap. Aviation runs on checklists. Update polar protocols to match the baseline we actually have. Predefine detour corridors. Plan fuel assuming DOP fades. Hit more often at high latitudes during active windows. Put radiation dose monitors in the cockpit where crews can see and log them. Tighten the handoff between HF and SATCOM. If one fades, the other is a button push, not a debate. Keep runway renumbering workflows lean. Align paint, approach plates, FMS databases, and training so the change lands once clean. And bring space weather into the same dashboard dispatch uses for winds, turbulence, and NOTAMs. If the shield will wobble on Wednesday, route planning on Tuesday should reflect it. Now, the part nobody loves, procurement. Write today's field into tomorrow's contracts. For satellites, demand radiation performance curves that reference current SAA maps and require on-orbit reconfigurability for thresholds. For avionics, automatic world magnetic model updates with date checks and validations tied to procedures. For grid gear, built-in GI syncing, remote visibility, and firmware you can patch without a truck roll. For timing, dual-source discipline beyond GPS, multi-GNSS where possible, paired with holdover oscillators that ride out hours of scintillation without drifting out of spec.
A few grams, a few watts, a few lines of code now beat a month of forensics later. Education turns procedures into muscle memory. Teach the magnetism layer early. Pilots learn weather. Add space weather thresholds and comm plans. Grid techs learn faults. Add GIC triggers and plays tied to local magnetometers. Satellite ops live this already. Share those lessons with small sat and university teams so they don't relive your worst Thursday. Make thresholds ordinary enough that no one argues when the color changes. Fragmentation is the enemy. Space.
Weather sits in one office, grid risk in another, aviation protocols in a third. Build a small permanent fusion cell, a daily briefing that pulls magnetometers, ionospheric scintillation, SAA exposure minutes, anomaly rates, and timing quality into one pane of glass. Color-coded, plain language with thresholds and actions. Think Hurricane Center, but for charged particles and drift. Publish the green days too. Habits form when nothing is on fire. Money talks. Insurers and reinsurers already priced this risk. Use that signal. A few million in sensors saves a few hundred million in outages. A kilogram of shielding saves a mission. A better holdover clock keeps a trading floor in sync when GPS jitters. Budgets hate the invisible. Put the dials on a wall and the budget listens. At home and work, it's simple. Keep offline maps on your phone. Use surge protection on the gear you care about. Backup files locally and in the cloud. If timing matters in your shop, finance, broadcast, telecom, add a second source and test failover. Run a no-cloud day once a quarter. If you fly often, expect detours during active windows and pack patience and power. Last piece, mindset. Curious, prepared, not doom scrolling. Treat the field like weather. Check, brief, act, move on. Share good sources. When someone says the core stopped, give them the line that motivates instead of scares. The field is dynamic, weak patches are manageable, we've got playbooks, let's use them. Because the river of metal under our feet won't pick a convenient week to breathe shallow. Our checklists decide whether that breath is a shrug or a story. The fast track scenario. Stress test the next decade. Let's run the most reasonable bad week. No meteors, no movie storms. Just a lively sun, a larger South Atlantic anomaly with that faster weakening lobe near Africa, and a still drifting pole that keeps forcing early magnetic model corrections. Press play on Monday. Monday starts in orbit. A medium geomagnetic storm pushes indices into the yellow. A weather satellite hits the SAA twice before noon, spending extra minutes in higher flux because the weak patch spread since last quarter. Safe mode scripts trigger a bit early and linger a bit late. 2 images that feed a floodplain briefing arrive after lunch. Nobody panics, but emergency managers adjust timelines, and downstream models slip a news cycle. Up higher, low Earth orbit breathes hard. The thermosphere puffs. A small imager loses altitude faster than planned. A propellant burn moves up a week. Lifetime estimates shave a month. A client milestone slides. The team writes the email that says updated schedule. Tuesday belongs to time. The same storm stirs patchy scintillation over the South Atlantic and into Africa. GPS accuracy bands widen in spots. On several cell networks, timing holdover gets tested. Most towers ride clean on rubidium clocks. A regional carrier that cheaped out sees drift, drop calls, and a throttled handoff zone. It's local and fixable, but the lesson is national. Redundancy wasn't optional. Unknown to them across town, a control room goes to posture. Magnetometers rock. GIC sensors nudge past the line that triggers procedure. Operators block automatic capacitor switching, bring extra spinning reserve online, and postpone maintenance on a 500 kV tie. Transformers that usually run cool pick up a degree, then 2. Not scary by itself, just the kind of heat that ages steel faster than spreadsheets like. Wednesday is the sky. 2 polar flights are already briefed on elevated blackout risk. HF is scratchy, SATCOM drops packets, dispatch nudges track south, adds fuel, and shifts duty times. Passengers miss connections, the airline eats cost and social heat. Radiation dose stays within limits, but dosimeters get attention, and the flights arrive late into crowded banks. Meanwhile, a small SAT cluster over the SAA logs triple the expected memory scrubs across the Africa lobe, exactly where new maps show the steepest gradient. One camera drops to safe mode mid-pass, missing a high-value scene. The ops lead widens the no-go mask and calls the client.
The satellite will be fine tomorrow. The invoice won't. Thursday brings a squall line of surprises. A sharper solar pulse rides in. In orbit, an older bird with stale thresholds hits an unmodeled trip because the weak patch moved since its rules were written. It reboots cleanly. The team pushes a patch to the fleet. At a ground station, support tickets stack, then clear. On the grid, alarms spike higher. GIC flows into numbers they see only a few times per cycle. Operators shed industrial load for 2 hours and keep a known weak transformer below a temperature that would cook it. A postmortem gets scheduled with a recommendation everyone knows: buy the spare. Friday looks calm, but the backlog lands. The flood briefing uses late imagery, updated after the crest. A city manager asks why those models missed the window. The answer: radiation, weak.
Patch. Safe modes doesn't fit a soundbite. In finance, a timing desk shows thin margins during the worst scintillation. The second timing source they've deferred gets greenlit. Money moves when graphs do. Saturday is hangover math. In Leo, drag totals show a handful of satellites use more propellant than planned. Lifetimes notched down. Downlink queues show lost minutes. Duty cycles shrink. Insurers flag anomaly clusters over the Africa lobe, ask for mitigation notes, and adjust deductibles if the SAA masks aren't current. At the airline, crew scheduling works through the detour ripple and logs the radiation watches for audit. The utility checks transformer temperatures and books an oil sample on the unit they ran hot. Sunday, the sun relaxes. Everyone exhales. Then procurement opens on Monday. Zoom out to the decade. On recent trend lines, the SAA keeps spreading. Not perfectly linear, not shrinking, and the West African lobe deepens. The worst box moves again, invalidating static rules written 5 years ago. Pole drift keeps nudging model cadence. WMM 2025 holds for a while, then surprises force earlier corrections in a couple of regions. Solar Cycle 25 throws a few more weeks like this. Early Cycle 26 repeats the pattern. Each week exposes where we underinvested. Satellites that needed 2 grams more shielding and an on-orbit threshold update. Grids that needed 1 more GIC sensor and a spare on the right rail line. Airlines that needed tighter polar corridors and faster WMM plumbing. Cities that needed shared dashboards with thresholds in plain language. What changes first if we're smart? Procedures and parts. Insurers price risk and push operators to show receipts. Shielding grams, ECC rates, updated masks, GIC thresholds tied to actions. Regulators fund magnetometers, spares, and training. Standards bodies bless dual source timing and automatic magnetic model updates. Small money moves lower big odds. And if nothing changes, the next storm week looks like this one. Same friction, thinner margins. Not apocalypse, just 1,000 small costs that add up. And on the wrong Thursday, a regional outage that didn't have to happen. A stress test doesn't predict collapse, it exposes choices. The field doesn't have to flip, and the core doesn't have to stop for this to matter. A wobble plus a busy sun is enough. The question the next decade keeps asking is boring and brutal. Do we pay grams, watts, sensors, and drills on quiet days? Or invoices, claims, and apologies on loud ones? Follow the models, follow the money. To judge the future, sit in 2 rooms. The lab where models argue with data, and the boardroom where risk gets priced. They don't speak the same language, but they stare at the same maps. The South Atlantic's softening footprint, the poles track, and the numbers that tell you how fast reality updates. Modelers start with ensembles because the Geodynamo is chaotic. Feed in the latest swarm-era field maps, assimilate global observatory data, then nudge the core mantle boundary heat flux within plausible ranges. In one branch, the South Atlantic weakens faster. In another, it stalls. In a third, the patch splits further while Siberia strengthens. The point isn't certainty, it's probability. Where is weakening likely by 2028? How much drift pushes WMM predictions out of tolerance by 2027? You don't forecast Tuesdays. You draw envelopes and measure slopes. Observation-driven models sit closer to the cockpit. The World Magnetic Model and IGRF digest ground stations and satellites to give you the field now, plus a 5-year forecast. When drift outruns expectations, as it did before the 2019 mid-cycle fix, WMM refreshes early. In December 2024, WMM 2025 landed to keep headings, charts, and devices within spec. That's not academic. It's what keeps a runway number, a ship's gyro correction, and your phone's heading from quietly diverging.
What's invisible from the outside is how uncertainty turns into rules. Scientists publish spreads and confidence intervals. Operators translate them into thresholds. If 60% of ensemble members push the SAA contour across this latitude by next year, plan as if it will. If the poll's forecast cone clips a region's tolerance band, schedule a model update earlier and line up the paint crews. Probability becomes procurement when you attach grams, watts, minutes, and dollars. Money follows those thresholds. Insurers don't care about spherical harmonics, they care about losses. Satellite underwriters now treat environment-driven upsets over the South Atlantic as expected conditions, not lightning from a clear sky. Show them shielding grams over the most sensitive silicon ECC rates for your memory, on-orbit threshold updates tied to current SAA maps, and your premium eases. Launch a fleet with commercial memory, stale masks, and no reprogrammability, and your deductible grows. Reinsurers fold geomagnetic variables into catastrophe models for utilities and airlines, a larger SAA.
Footprint during solar maximum shifts capital and raises questions in boardrooms that don't read space physics. Procurement moves next. Agencies that ship WMM updates budget for faster integration across fleets. Ships, aircraft, survey gear, even smartphones that carry the model in code. Space companies pull rad hard parts earlier, eat lead times, and add selective shielding mass around timing and power management. Mission designers shove an extra tweak burn into the propellant budget to fight drag during active years. Utilities order GIC sensors in packs and write firmware that ties thresholds to actions. Block switching, hold voltage, bring reserve online. Without waiting for a phone tree, these aren't press conferences. They're purchase orders that assume the map won't sit still. Government signals set tone. When a regulator mandates GIC monitoring and publishes thresholds tied to space weather alerts, bond markets price resilience differently. When a standards body updates timing guidance, dual source discipline beyond GPS plus holdover clocks that ride out hours of scintillation, finance desks buy oscillators instead of crossing their fingers. When a space agency funds magnetometers, ionospheric monitors, and a swarm-like follow-on, that's a forecast in budget form. The field's patchwork will matter to operations, so measure it better. A micro story from that money room. A reinsurer's analyst overlays SAA footprints from 2014 and 2025 on a constellation's upset logs. The slope is shallow but real. They bump the modeled frequency for single event upsets over the Africa lobe and adjust portfolio exposure. Overnight, quotes creep up for operators flying commercial memory. One CTO pushes back with receipts on orbit ECC performance, new masks that reflect the lobe's drift, and selective shielding added on critical boards, the premium trims. The model didn't just predict, it negotiated. Meanwhile, venture analysts read KP indices and anomaly rates, like coastal investors read hurricane tracks. They ask dull questions that move capital. Upset rate per orbit hour inside the SAA, duty cycle loss per week, drag-induced altitude loss per month during active windows. Dull is where the money turns. If the answers trend up, term sheets grow caution lines. Prove mitigation or accept a discount. Here's what to watch if you don't live in those rooms. 3 dials tell the story. First, model cadence and corrections. If WMM and IGRF update early or with bigger regional adjustments, the system is moving faster than expected. Second, regional intensity maps. If the South Atlantic's minimum deepens and spreads, assume satellite duty cycles and upset rates change, and expect small ZATs to pay first. Third, pricing. Insurance terms for LEO operators, utility bonds tied to grid hardening, airline disclosures on polar detour frequency. Those prices are seismographs for quiet shifts. Uncertainty is the headline in the lab. In the market, it's a surcharge. Follow the models to see where the field breathes next. Follow the money to see when that breath turns into policy, parts, and procedures. Verdict on the core is stopping. Here's the clean verdict. The core isn't stopping. The strongest evidence says the inner core's rotation has slowed relative to the mantle, likely part of a multidecadal oscillation, with hints of slight backtracking and year-scale changes at its top. That's a gear shift, not an engine stall. But gears matter. When that relative motion changes, it can tweak the flows in the outer core, the Geodynamo's fuel lines, on timelines we notice, years to decades. Translate that into what you live with. A variable engine doesn't flip a master switch, it redraws the map. Strong here, soft there,
a pole that wanders fast enough to force model updates and runway paint, a South Atlantic patch that spreads and deepens while Siberia strengthens. Operators don't manage a number, they manage a patchwork. That's why satellites schedule SAA naps, why dispatchers load fresh world magnetic model coefficients on a calendar, and why insurers keep asking for SAA masks and error correction rates before they quote you a premium. So why does stopping stick? It's tidy. One word turns a subtle oscillation into a cliff. The price of that tidy word is trust. Say stopping, people expect apocalypse or a debunk. Reality lives between. A long wobble that raises failure rates in tech built for yesterday's sky. Not every week. Enough weeks to move budgets, training, and procedures. Stakes climb quietly. A wobblier baseline plus a lively sun equals more single-event upsets, more safe mode minutes over the South Atlantic, more drag on low orbits, wider GPS accuracy bands during scintillation, more polar detours, and higher geomagnetically induced currents warming transformers for the same storm. That's not a flip. It's friction that shows up as overtime, spares, shielding grams, and schedule slips. What this does not mean: no field, instant flip, extinction. Reversals take thousands of years. Excursions compress stress into decades. A field persists, messy and patchy through both. The modern vulnerability is technological. Timing, comms, power, navigation. Those break when we underinvest in boring things that work. ECC memory, GIC sensors, dual source timing, automatic WMM updates, and dashboards that tell adults what to do on yellow and red days. So keep the headline accurate and useful. The core is wobbling, not stopping. The field is reorganizing, not vanishing. The risk isn't doom on Tuesday, it's a decade where routine storms cash in every deferred decision. Treat magnetism like weather. Measure it, brief it, and act before the next storm asks if you did. When the field taps you on the shoulder. 30 minutes into cruise over the pole, the captain hears it. HF fading. He checks the dosimeter, then the line in the dispatch packet that flagged elevated blackout risk. The secondary frequency is static. SATCOM drops a few packets. The choice isn't dramatic, it's procedural. Turn south early and burn the extra fuel, or press on and risk dropping below company.com thresholds. He banks. 200 people groan at misconnections. Up front, the entry in the logbook is short. Detour per playbook during active window. The magnetosphere just sent a memo. The crew wrote the response. Across town, a satellite ops lead watches her dashboard blink yellow as their imager drifts toward the South Atlantic Anomaly. The West African lobe deepened again. Last quarter's masks are already tight. Safe mode scripts arm. Detectors stand down. The spacecraft coasts through the bight and wakes on time. The downlink later shows a gap where a coastline should be. The client's email is immediate. Deadline missed. She doesn't argue. She circles the cluster of memory scrubs in the log, widens the no-go box by another sliver, and adds a slide to Monday's review. More shielding next build, fresh masks every quarter, renegotiate deliverables for SAA passes. The image will be fine tomorrow. The invoice won't. On night shift in a substation, an engineer stares at a graph most people never see. Geek creeping past a line he knows by heart. Magnetometers tick higher. He reaches for the laminated card taped to the console. Block automatic capacitor switching. Hold voltage set points. Call for extra spinning reserve. A transformer that ran cool all week warms by 2 degrees. Nothing anyone would notice unless you're the one who changes the oil and reads the dissolved gas analysis. He sheds a slice of industrial load for an hour, keeps the big steel out of the danger zone, logs the event, and reopens an old request for a spare that's been sitting in procurement. The lights don't flicker. That's the point. In a hangar at dawn, a maintenance chief signs off on the nav database cycle and double-checks that the runway renumbering at a coastal field now matches the paint, the plates, and the FMS. It's a sleepy job, all checkboxes and cross-checks until it isn't. A half-degree mismatch on a low ceiling day breeds confusion right when you can't afford.
He pushes the update to cruise, pings the tower, charts and paint match. Drift stays a note in a brief, not a problem to flare. A startup CTO stands at a whiteboard with a triangle labeled Mass Money Margin. Their CubeSat camera is perfect, except for the memory that trips too often over the Africa lobe. 2 grams of selective shielding would cut the scrubs in half. 2 grams means a different deployer and a fee they didn't budget. She calls their insurer, puts swarm-derived weak field contours next to on-orbit upset rates,
and proposes a trade. Invest in shielding and adopt an error correction scheme proven on another mission. In return, a premium that doesn't crater their runway. The underwriter nods at the receipts. Risk turns into parts and code, not vibes. A survey ship rolls through gray Southern Ocean swells while the navigator frowns at a compass that won't stop arguing with experience. GPS is fine, but the magnetics are part of the workflow. He pulls the World Magnetic Model 2025 coefficients into the system. The heading snaps back in line with the sea. He logs the correction and radios the next watch. Don't trust the needle without the model. His grandfather sailed these waters with a swinging compass and a pencil. He sails with software that carries the same math, updated mid-rotation, because the pole didn't wait for a maintenance window. In a city emergency office, a planner briefs a mayor on why a warning landed late. The slide is simple. A satellite lost minutes in the South Atlantic. The replacement filled the gap. The river under our feet is breathing shallow, and storm days are louder over weak patches. 3 dials sit on the screen. Geomagnetic activity, SAA exposure minutes, GPS accuracy bands, with colors and actions. Green is normal. Yellow is prep. Nudge schedules, pre-position crews. Red is execute. Change routes, hold power, warn the public what will actually happen. The mayor nods and moves a budget line. Decisions follow dials. Last one lands where you live. A commuter plugs in at home. The surge protector hums quietly between the grid and the laptop. Offline maps sit on the phone because no bars and jittery GPS shouldn't mean no plan. Backups ran last night. No one claps for any of this. But on the week when satellites nap longer, grids run hotter, and flights slide south, the small, boring choices are the difference between a shrug and a story. The field taps. You don't need drama to answer. You need a checklist. What you can do next, personal plus civic. No panic, just moves that turn a wobble into a shrug. Start with the simple stuff you control. Give yourself a backup way to navigate. Download offline maps, so a jittery GPS or a dead cell zone isn't a dead end. Keep a small battery bank charged. It turns a short outage into a non-event. Put surge protectors on the gear you care about. Computers, routers, NAS boxes. When grids run hot during storm windows, weird voltage swings show up in the worst moments. Backups matter more than opinions. Set weekly local backups for critical files, not just the cloud. If your work relies on time, home lab, cameras, trading terminals, use a decent router with a stable clock or add a low-cost local time source so brief GPS or internet timing dips don't throw you. Stay storm-aware without doom scrolling. Bookmark the official dials. NOAA space weather alerts, ESA swarm visuals, your National Space Weather Service if you have one, and your utilities grid status page. You don't need to speak KP. Learn the traffic lights. Watches and warnings mean plan for comm hiccups, timing jitter, and grid stress. If an alert says HF radio degraded at high latitudes, expect polar flights to detour and SATCOM to get patchy for a bit. Treat it like rain. Adjust plans, don't spiral. If you travel or crew flights, be practical. Frequent polar flyers. Expect occasional detours during active windows. Pack patience and power. If your crew, keep comm handoffs sharp, HF to SATCOM and back, and use the radiation dose tools your airline provides. Dispatchers already blend space weather into the brief. You'll feel it as extra fuel, southbound tracks, or time buffers on busy days. At work, continuity beats wishful thinking. Run a no-cloud drill for a day. Can your team operate if logins lag or shared drives stall? If timing matters, finance, telecom, broadcast, add dual timing paths. GPS-disciplined oscillators are great. Pair them with holdover clocks that keep you in spec for hours when GPS or GNSS gets noisy. Test failovers like you test fire alarms. Quiet weeks are where gaps show up safely. For operations teams, IT, OT, field crews, tie action to thresholds. Build a one-page checklist for storm watches and warnings. Watch list, defer non-urgent maintenance on critical gear, verify backups and monitoring, confirm on-call coverage. Warning list, increase monitoring on known hotspots, long lines, old transformers, overloaded racks. Lockdown automatic switching that can misbehave under stress. Stage spares and portable gensets where you've needed them before. Document your thresholds in plain language. If this dial crosses that line, do this action. Then practice it. Civic is where small choices scale. Push for public dashboards that mirror the operator's view. Magnetometers, GIC at substations, ionospheric scintillation, aviation advisories, GPS accuracy bands, color-coded with simple actions. Green means normal, yellow means prep, red means execute. Ask your utility if they have GIC sensors and space weather procedures. If not, ask when they will. Support budget lines that buy transformer spares and substation sensors. They're not flashy, but they buy time when time is scarce. Keep runway renumbering workflows tight in your region. That means coordination between paint crews, charting, FMS databases, and training when WMM updates land. It sounds small until a half-degree mismatch meets low ceilings. Airports and local governments can post clean public notes on navigation updates so pilots and hobbyists don't live in rumor. Schools and training programs can turn this into muscle memory. Pilots learn weather, add space weather thresholds with comm plans and dose watches. Grid techs learn faults, add GIC triggers tied to local magnetometers. Satellite teams already swim in the SAA. Share those habits with smallsat and university programs so they don't discover the Africa lobe the hard way. Build a small fusion cell if you can. City emergency office, utility, airline station ops. One room that pushes a daily brief across sectors with the same colors and actions. Publish the green days so habits form when nothing is on fire. Procurement is leverage. If you write specs or sign checks, make today's field explicit. For satellites, require radiation performance curves that reference current SAA maps, on-orbit reconfigurability for thresholds, and ECC on critical memory. For avionics, automatic world magnetic model updates with date verification. For grid gear, built-in GIC sensing, remote visibility, and firmware you can patch without a truck roll. For timing, dual-source discipline beyond GPS, multi-GNSS where possible, plus holdover oscillators that ride out hours without drifting. A few grams, watts, and lines of code now beat a month of forensics later. Last piece is mindset. Curious, prepared, not doom scrolling. Treat magnetism like weather. Check the dials, brief the thresholds, act, and move on. Share good sources. When someone says the core stopped, hand them the useful sentence. The field is dynamic. Weak patches are manageable. We have playbooks. Let's use them. The river of metal won't pick a convenient week to breathe. Our habits decide whether that breath is a shrug or a headline. A long wobble is enough to strain a world built on timing and thin margins, and it's quietly asking if we'll prepare on purpose or pay by surprise. If you want the play-by-play of a storm threading grids, planes, and satellites, watch our Space Weather Blackout episode next, and subscribe so the next alert arrives with context, not panic.